Okay. So, you guys know your calculator can do a least squares regression line. You also know that you can linearize nonlinear data. And I had given you questions out of this book last year. Yeah, there was a scan and the questions are out of this book. Abby gets that Wednesday? I think it's Wednesday. Sometime this week. Um, so the equation to do the least squares regression line by hand, was that in the video last week? And remember that the regression line is y hat, or predicted y, a plus bx. The a plus bx, it doesn't really matter which one. It's just easier to do it in that order when you're linearizing nonlinear, to put it back. Okay, your answers in this will be an a plus bx form. When you do it on the IB test, you're just going to use your calculator. If you give it an mx plus b, I don't care. They won't care. Okay. IB tends to be not fussy on the it doesn't matter details. Okay. If there's three correct ways to do it, you can pick whichever one of the three. For the sake of this, I don't really care what you write on the test, but if it's multiple choice, which some of them will be, it's going to be a plus bx form. You should be able to rearrange that even if you do the other one on your calculator. Um, so yes, you notice that formula is a pain in the butt if they don't give it to you. You will never use that formula unless they give you all the values. But back in the old days when you had to do that by hand, do you remember how hard the correlation formula was? And yes, you would have SX and SY doing that, but those are a pain to calculate by hand too. You got to figure out each one's distance from the mean, each value, square them, add them all together, divide by n minus 1, square root it for x and y, and then correlation, I can't remember what it was. No, correlation uses both. I think it multiplies each one's x times each one's y. You probably want to use the table method that we taught in Carnegie, where you actually the stats unit in Carnegie was one of the best ones I've ever taught on. Yeah, about the only thing I liked out of that book. There were a couple of things, there were a couple other activities, and like I like this one activity. There were like four or five that I liked in the integrated one book. Four or five lessons, that's it. But the stats unit was actually very good. And what they do is you make a table, you've got x, you've got x minus x bar, you square it, you add them all together, and you could then take that squared column and multiply them and add them. I think you multiply the x, the deviations in x squared and deviations in y squared, and then divide for correlation. But it'd be a very big pain in the butt to calculate by hand. And yes, they used to do it. Okay, so what is the meaning of R? Correlation coefficient, it means what?
From to
To a line. The true meaning of correlation is only linear. Okay? They will put one on so in your Inspire can put it on for nonlinear, and it'll put R squareds on. The true meaning of R is only for linear. Okay? So the R value probably comes from if you remember, we logged axes to make them linear last year. Um, that's where your R is coming from, I believe. R squared has another way of calculating it, but it is the same as literally squaring the R value. Okay? There's an alternative way to calculate it, which I think is why it actually works on some of the other ones. Okay? They might just be square rooting R squared when they give you an R value. Remember, negative R's mean negative slope. Positive R's mean positive slope. Close to 1 or negative 1 is good. Close to 0 is horrible. Zero point 0.5 is actually pretty bad. R squared. Do you guys know that meaning? No. It is the percent of y that can be predicted by x. R squared. Percent of y, and you will be required to put them in the context of the problem. One of my favorite ones from chapter 14 in this book, you can get the percentage of a baby's intelligence that could be predicted by the amount they cry. About 23%, which isn't very much, but 23% of a baby's intelligence can be predicted by how much they cry. Dumber.
Yeah, that makes
Okay.
It should not be rewarding.
Like neglect.
That will also lead to them being dumber. So notice it's only a 23% predictor, but that's not zero. Okay? So, you see how I put that into the context of the problem? That is what you guys have to learn how to do for everything, but specifically for stats. They will really harp on it for stats. But there's almost always a point at the end of any of the longer problems for telling your answer, what does it mean in the context of the problem? Okay? Um, they're usually relatively easy points, yes. If you remember to do them and you're clear. It will not be as easy in some of the stats ones. Okay? Some of these will be challenging to interpret correctly. Okay, they call this the least squares regression line. Okay? So, it literally means my points are here, here, and here. The distance here is 3 to the predicted. Predicted is the line. So that's 9 squares, right? 9, 9, 36. The idea behind the least squares regression line is you are using the line that will give you the least squares. Okay? And there's the nice formula is there to given to you to use. Your calculator does it, but that is the theory behind what it is doing. It is minimizing the square of what's called the deviation from the line for all the points. Mm-hmm. The line? The line here is diagonal. The deviation, no, it has to be vertical. So this one is the deviation for x value 3. It's not the shortest distance. It's the vertical deviation. Because this is the value for 3 versus the predicted for 3. That makes sense? Which is actually way easier to calculate than the shortest distance. That makes sense about r squared. You don't really need to use the complicated r squared formula. R squared is called the coefficient of determination.
Ooh, that's tough.
Okay. R is called the correlation coefficient. R squared coefficient of determination.
No, that's like tough. I don't know why Oh,
So,
I'll make it one fishes.
facts about least squares regression. The distinction between an explanatory and response variable is essential in regression. It does not matter in correlation, but it does in regression. When you switch y and x, it matters. You will still get the same correlation, but you will not get the same regression line. Okay? So this is data for the expanding universe. You guys kind of know that the universe is expanding, right? Yeah,
You taking the course on?
she's in physics. Yeah, that's part of it. So notice what happens when you switch y and x. You get different lines. It doesn't mean that they can't ever be switched, but you do not get the same results. Fact 2. There's a close relationship between correlation and the slope because R is part of this correlation. Okay? Calculation. The worse the correlation, usually the flatter the slope. Okay? Fact 3, this one's important. The least squares regression line always passes through the point x bar, y bar. That's involved in the a value or the y-intercept. Okay?
That's where I'm not sick, just Joe's.
Good, because I don't want to get sick. I don't want you to be sick. You got too much work to do.
No key.
You're like, yeah. So, the fourth one, I don't remember. Fact 4. Correlation describes the strength of the straight line relationship. R squared is the fraction of variation of y that can be explained by x by the least squares regression line, y on x. No. No, that's a logic puzzle. Bill.
Wait, Mr. Schwartzman, did you ever had to like lay down and put in some cardboard? Just off topic.
Have I ever had to install carpet?
Yeah.
I've helped install carpet before.
Is it not
Like this.
when you like
Use knee pads.
I did and then it hurt so awkward.
Oh, yeah. So go to Harbor Freight, spend like $18 on some gel knee pads, and they really, really help.
Because like how one was bad.
Okay, so anyways, we need to keep going. So you remember the Sanchez family and their gas thing? That was an earlier example from last week, right? So we can see that their R is 0.9953 and their R squared is 99.06. So 99.06% of the variation in gas consumed per day can be predicted by the heating degree days.
That's really good.
That's really good. The Hubble one that I just showed you has an R squared of 61.5. So 61.5% of, I need to look back. The velocity can be explained by the distance. That makes sense? The velocity of expansion. Okay, do you guys know what residuals are?
Let you know.
Distance from the line.
That one's each individual distance from the regression line. The person that didn't do this at integrated one remembers.
They did. Did it with this.
Oh, okay. You guys did get there. That's good. And it's like, Izzy did it with me, Devin did it with me, Rowan did it with Mr. Klein.
Ooh, and then I get in.
So basically, this is observed minus predicted is residual. Half the residuals will be 0. Or negative, not 0. If you add up all the residuals, it should be 0, which is why you square them. Okay? So,
Observed y minus y.
or y minus y hat for each value. Each value has a residual. Okay? So each x that has an actual value also has a residual. If you've made regressions and you go back and list, you'll see stat.resid in your calculator. That is a list of the residuals. It generates it for you. You can, it will generate it automatically. You can put it in a list. If you put it in one of the columns and hit stat.resid, it will list out all the residuals. Okay. Very useful. Okay. You guys saw this data before, right? So we have child 19 is an outlier. Child 18 is what we call an influential observation.
Because it's not quite an outlier.
It's an outlier in the x direction.
Okay.
So influential observation means outlier in the x direction. It will drag the line towards it massively.
Influential one.
Influential observation. I'm not sure if I spelled that right. I'm not sure if this is a C or a T.
It would be.
It's a T. Okay. So if we're looking at this, we get an R score, an R value for this data of negative 0.640. I mean, it's not great, but that's not that bad. R squared, 40% of the later score on an intelligence test can be predicted by when they spoke their first words. That's not that bad. It's not great. If we take out observation 18, which not speaking till 40 months, yeah, it's like 3.5. It's like 42 months. That probably means they have some sort of developmental disability, right? So we take out that kid. We just remove them from the data. Um, we get an R squared of only 11%.
Wait, that makes the R worse?
Yes.
Because the data.
The data is being dragged to that and it looks linear when it's not very linear. Okay. Influential observations. You make a scatter plot here with absolutely no pattern in it. And then you put one out here. You will get a relatively decent line. Because this drags everything towards it because its X is so much different. Okay. You'll get even though this was basically no correlation, you put one observation way out on X, and you will get something of some significance. Okay. Residual plots. A residual plot is a plot of all the residuals. You take your X coordinate from your points, you graph X versus residual. Okay? I will show you how to make a residual plot in a second. If the residual plot has a pattern, any pattern that is not just randomness, linear was not the right choice. Okay? Do you see a pattern in this one? The variation is getting bigger, right? As X gets bigger. Um, that means there's something there, and I don't know what type of. The curved one I can say was probably quadratic. This one I should have used a quadratic regression on, most likely. This? Very, no. No, you do not try to match. Generally, don't try to match it to the pattern. You'd want to look at the original data and look for what shape it is. A lot of the curved ones are powers or quadratics, sometimes exponentials. Um, this basically is probably going like this with our data. It's getting more spread out, and it might not fit regression. There might not be a regression model at all for it. Okay. To do a residual plot, I'm going to put in a few random points. I haven't done one in a while, but I think I still know how to do this. Put in, 5 points in your calculator. Doesn't matter what they are. We don't have to all get the same one. So I've put in some random points. I'm going to make a data and statistics graph. I really didn't care what I labeled these. So I've made my regression. You don't know how to make a linear regression?
Oh, no.
And it's like, you don't know how to make a linear regression. I fail you from pre-calc. I go back and change your grades.
It's not a while.
So, menu, plot type. Is it plot type? No. Oh, analyze residuals. Show residual plot. Do I have a pattern in mind?
Yes.
No.
Oh, you mean your residuals?
In my residual plot.
I didn't-
Does everybody get the show residuals? Yeah, like I said, it's been a while, but I like the Inspire because it's in menu. I just went through the menus until I found residuals. Yes. You don't want the squares is going to make that drawing like we had on our thing. Yeah. And that's not particularly helpful. Everybody got that? Able to see residuals?